Okay, what I want to do is to work through most, if not all, of the homework problems for Module 7 and Module 8, or we could think of them maybe as Week 7 and Week 8 if it's a 16-week class, for MATH136 Online. So once again, I'm going to work through these homework problems, explain how to do them, and then I hope to take about 15 minutes per video and work through all the problems. And once again, the problems on the test will look something like these homework problems. So hopefully this will help you as you prepare to review and study for the test. So hopefully the homework problems you have are the same exact order as mine. May not be the same exact problem, but it should be the same type of problem. For instance, problem number 1, let me just read it, and then I'll write down the important thing. It says, use the quadratic formula to find the real solutions, if any, of the equation. And then it gives us this equation. So we have x squared minus 4x minus 13 equals 0. Now as I'm going through these problems, I'll try and make a few notes and a few things explaining how to go about working these problems. For instance, this one is called a quadratic equation. Quadratic equation is when you have the variable squared. Now this is a trinomial, which means there are 3 terms. There are a couple of different ways that typically you go about trying to solve this trinomial. Once again, the goal is to solve for x. In other words, that means just find the value of x that makes this equation true. Sometimes there may be more than one number. All right, so quadratic equation, typically when we try and solve these, most of the time we try and get all the terms on one side and 0 on the other. So in this case, the problem was given to us like we want. Something you can try and do is to factor. Sometimes if some of you like to factor, if I look at this quickly, this actually does not factor. So in this case, factoring is not an option. So most of us end up using what's called the quadratic formula. And actually, I brought with me, when you get ready to take your midterm exam, you will have access to a formula page. And honestly, there's not actually not a lot on this page that I think is very useful. But for this problem, there is one. And this is called the quadratic formula. And you'll actually have access to this on the test. And that's what we're going to use here. So let's explain how this works. First of all, let's write out sort of a generic quadratic equation. Ax squared plus bx plus c equals 0, where a, b, and c are just numbers. If you have a quadratic equation like this, then we can actually find the solution to this equation by using this quadratic formula. And this is what was written on the formula sheet. Negative b plus or minus square root b squared minus 4ac over 2a. So all you do when you have a quadratic equation, you figure out what your a is, what your b is, and what your c is, and you plug them into this formula, and then you have your solution. So it's pretty straightforward. So for our problem, looks like a is 1, b is negative 4, and c is negative 13. Usually when students miss a problem like this, it's because they're not careful with their math, and usually it comes down to being careful with negative signs. Notice here the b and the c are both negative numbers. So now let's plug in the A and the B and the C into this equation and see what happens. This is a little tricky. It's negative B. So what I always do, I write the negative first, and then I put in my B. In this case, B is negative 4. So really, I have a negative 4, plus or minus B squared, so negative 4 squared, minus 4 times A, which is 1, times C, which is negative 13, and all this over 2 times A, or 2 times 1. So now it just becomes a problem of doing this calculation. And we just have to be careful. A negative 4 is 4, so 4 plus or minus. Under the square root, negative 4 squared is 16. Now notice here I'm subtracting, and then I'm multiplying two numbers times a negative. So actually 4 times 1 times negative 13 is, I believe, negative 52, but I'm subtracting a negative 52, which means I'm really adding 52. And then all this is over 2. All right, let's keep going. So 16 plus 52 is 68. All right, so now here we have to do a little bit of math, because whenever we have square roots, we always have to make sure it's simplified. So I have to see if maybe I can reduce this 68. So I have to sort of think to myself, you might want to grab your calculator. For instance, how about, can I multiply something by 4 to equal 68? Turns out I can. So just to make it very clear what happens here, and square root of 4 comes out as a 2. So I end up with this. Of course, I'm not done yet, because now I notice I have two terms in the top, a 4 and 2 squared is 17, and in the bottom a 2. I have a common factor. In other words, I can divide the top and the bottom by 2. So when I do that, I end up with 2 plus or minus square root of 17. Now, when you take your test online, they don't allow you to write it like this. So what you will do, when you enter your exam, you can put, doesn't matter which you put first, the plus or the minus. So that's one solution. And then the second solution, and typically they have some kind of brackets you put these in. All right, so that's solving this equation. If you have time after you finish the test, you could actually plug these in and check your solution, but it'd be pretty ugly because we have a square root here. So the main thing is just be careful with your math, and then there you go. And by the way, don't forget, on your exams, they will send me, if you take the test at a Navitech site, they will send me a copy of your scratch paper. So what you need to do is do what I just done here. Problem number 1, if you show your work, even if you happen to make a math error, but you're doing the right thing, I can give you partial credit. But I can only give you partial credit if I can see your work and it's organized and I can even see the problem. So this would be perfect for me to check. And even if you make a math error, if I saw that you were doing the problem correctly, I would probably give you most of the credit. Even though on the computer, it'll give you a 0, because it's looking for the exact answer. If it was me and you just made a simple math error, I'd maybe give you 75% of the problem correct. So that's why it's very important to show your work and to keep it organized. All right, let's do a second problem. I don't even know how long. I should have written the time down, how long I took on that first problem. Second problem looks like it's a problem with complex numbers. If you recall, these numbers I. And this simply says, write the expression in the standard form a plus bi. Let me write that down. Say, want your answer in the form of a plus bi. And of course, a and b are just going to be numbers. And the actual problem is, it looks like we're going to multiply two complex numbers. Now, if you remember, a complex number has two parts. It has what we call the real part, and then it has what we call the imaginary part. The real part is just the number, and the imaginary part is the part with the I. So in this case, we have two complex numbers, -5 plus I times -5 minus I. -5 and -5 are the real parts. The imaginary parts are I and minus I. Now, the way I like to teach complex numbers is to keep it pretty simple. I like to think of I, even though it's not a variable, it's not like an X or a Y or an A, but in terms of the math, it's okay to sort of think of the I like a variable. Just like if I were to multiply 5 plus x times 5 minus x, I think most of you probably learned to use FOIL. And when you FOIL this out, maybe I'll skip a step, but I think if I'm careful, that ends up being what happens when you multiply it. I'm going to do the same thing here. I'm just going to do FOIL. Matter of fact, here I'm not going to skip a step. -5 times -5 is 25. -5 times -I, so I'm multiplying two negatives. Matter of fact, here, well, I'm trying to think whether I did this correct or not. I think I did. Actually, I did not. That's what I get for skipping a step. Just to be safe here, 25 minus 5x plus 5x minus x squared. Wow. All right, good thing I found that. Some of you may have been screaming at me when you saw this. So let's complete this. So now I times -5 is -5i. I times -I is -I squared. Now at this point, we have to realize that I is really not a variable. And the main thing is we have to realize whenever you have an I squared, you have to remember that I squared, let's talk about complex numbers for a minute. Complex numbers, the whole idea of I equals the square root of -1. So what would I squared be? Well, I squared would be I times I, which is square root of -1 times square root of -1, or I could write that square root of -1 squared. What happens when you square root? You're just left with what's inside. So the key thing you have to remember, I squared always gets replaced with -1. I squared equals -1. So now, if I continue this, first of all, I have 25. I have 5i minus 5i. It's almost like combining like terms. These are like terms. It turns out they cancel out. So I'm just left with minus I squared. Minus, but I squared is negative 1. So I have 25 minus a negative 1. Subtract a negative 1 means 25 plus 1. And there's your answer. Turns out, oftentimes when you work a problem with complex numbers, you end up having an I in your solution. Matter of fact, it told us to put your answer in this form. This is one of those cases where when you get all finished, there's actually no imaginary numbers. It's just a regular real number. All right. Let's do one more, and then I'll stop this video and start another one. Let's finish out with number 3. Instructions for number 3, it says find the real solutions of the following equation. So basically we're trying to solve this equation. In this case, it's a cube root, it's a 3 here, of 3x plus 2 plus 3 equals 5. So here's an equation. Now the key is, this is an equation with one radical. I think in a little bit we're going to have another problem to solve where the equation starts out with 2 radicals. But when you have one radical, the way you're going to solve it is you get the radical by itself. That's the first step. Get the radical by itself on one side of the equation. So to do that, I'm going to subtract 3 from both sides. So I end up with the cube root of 3x plus 2 equals 2. Now once you have the radical by itself on one side, once again, my ultimate goal in this problem, I'm trying to solve for x. It's almost like I'm trying to take this equation and I would like to get x by itself on one side. Well, right now, my variable x, I like to say it's stuck underneath this radical. It's stuck underneath this cube root. How do I get it sort of free so I can solve for it? What I really need to do is I really need to get rid of this cube root. Now, a lot of times we've done problems with square roots, so a lot of you guys are familiar with the square root. Say I was solving this equation. If I want to solve for x, how do you get rid of a square root? Well, you square it. Of course, I can't just square one side. If I square one side, I also have to square the other side. So then you would have this. Here, however, we have a cube root. We don't work with cube roots as much, but the same principle applies. I want to get rid of or negate or cancel out a cube root. So what do? In this case, you actually cube it. Just like over here, you square a square root. Well, here, I'm going to cube a cube root. But of course, I have to cube both sides. So when you cube a cube root, you're just left with what's inside. And 2 cubed, please, I've had students do this. They look at 2 cubed, and for some reason they just want to multiply these and call it 6. It's not correct, right? 2 cubed means you multiply 2 by itself 3 times. So 2 cubed is 8. And now, it's a pretty simple equation to solve. Subtract 2 from both sides. Divide both sides by 3. Now here's a very important point. Whenever you're solving an equation that starts out with a radical, you have to check your solution. That first problem I did, if I have it somewhere, I don't have it with me. That quadratic I solved, oh, here it is. When I did this problem, when I solved this equation, here's my solutions, and I told you if you want to, you can check the solutions. It's not necessary. In other words, if you do the math correct, you will get the correct answer. However, when you start an equation with a radical, you have to check your solutions. Sometimes you can do the math perfectly, but when you plug in your solution, it doesn't work. That can happen. So it's not optional. You have to check your solution. So what you do is, I plug in 2 for x in my original equation and see if it works. So here's the check. So it's cube root 3 times 2 plus 2 basically I'm saying when I plug in the 2 for x, is this equation true? Well, 3 times 2 is 6. 6 plus 2 is 8. Cube root of 8 plus 3 equals 5. Is this true? Well, the cube root of 8, cube root means what number can I multiply by itself 3 times? That equals 8. Cube root of 8 is 2. So at this point, hopefully you can see that, yes, in fact, x equals 2 is the solution. All right, I'm going to stop now, and I'll pick up again with problem 4 in the next video.